Good afternoon, everyone. I welcome you to our maiden TQ webinar series. Today's topic is we're doing the series on developing a machine learning model, right? Where we'll be doing an introduction to data science, and then we're going to be reviewing a couple of learning objectives. So I welcome you. We have participants from all around the world who are joining us in today's live stream. So I welcome both the Zoom audience and those also joining us on YouTube Live. You're welcome. We are super glad to have you join us this lovely afternoon or morning or evening, wherever you are. Yes, who's excited? Okay, so before we begin today's webinar, I would like to list a few roles. I'm not sure I introduced myself. My name is Olumide. I'll be the moderator for today's session. I'm the operations manager at TechQuest Academy. So yes, let's review the rules so that we'll have a lovely session and a productive time here this afternoon. So could you please start by proceeding to the chat section to introduce yourself, your name, where you're joining from, and what you hope to gain in today's webinar. It would also be great if you have a notebook and a pen handy, right, to take notes and to jot a few things down. So at every point in the webinar, please ensure that your mic is always on mute. And if you are just joining the call, please proceed to mute your mic so that we can hear ourselves clearly and have a productive conversation. If you have any question at any point, please proceed to the chat section and do a search for TechQuest Academy and drop us a question. You could also, when the webinar starts, you could also drop your question in the regular chat channel and we'll pick it up. But if you want me to be able to sift through the various comments and questions, please send your messages or your questions directly to TechQuest Academy, right? Let's start with an introduction. Let's introduce Moyosore as lovely facilitator for this webinar. So yes, let's start with Moyosore's profile, short profile. So Moyosore Lawal is a data professional who has worked with data in numerous ways and has a well-grounded understanding of the data lifecycle. She currently works as a senior analytics associate at Syntelli Solutions in the US. And as a data scientist and engineer, she has managed several successful projects, building and implementing predictive models and data solutions from many industries. She earned her MSc degree in data science and business analytics from the University of North Carolina in Charlotte in the US, and she serves as a mentor for the computer science department. She's also one of the organizers of a Charlotte-based data science and business intelligence meetup group. And in her spare time, Moyo enjoys spending quality time with friends and family, reading, planning, and contributing to the community. As one of the organizers of a Charlotte-based data science and business intelligence meetup. And in her spare time, Moyo enjoys spending quality time.
I'm still gonna listen to it.
Okay, so yeah, contributing to the community. Sorry about that. Moyo, we're glad to have you here. You can start the session, please.
Hi, thank you. I was looking through. It's nice to meet everybody here. I'm going to share my screen now. And be sure no one can write on the screen. Okay. All right. So, okay, this is my introduction to data science. Just a minute. So we're developing now. Just a minute.
So while we wait, everyone, you're welcome. Raphael, Lawson, Christopher, Pascal, David, Ogunse Olaoluwa, Ovie from Lagos, Michael, Abimbola, Sejeri, Miriam, Hijiro, everyone, you're welcome. We hope this would be a very productive and exciting time walking you into the lovely world of machine learning and data science and demystifying various concepts in the field of study.
Okay, thank you. I really need to learn how to use Zoom very well.
Okay, do you need some help?
I'm looking for my Zoom application. Okay, Zoom, where you at? Okay.
Awesome.
All right. All right, so sorry for that. Welcome to Developing a Machine Learning Model. My name is Moyosore Lawal Balogun, and today we're going to learn the fundamentals of data and data science. So it's not just all going to be data science. We'll watch a video. It's the same video as what the younger ones watch. So if you had your kids watch that one, I'm sorry, you have to watch this again. We'll talk about some use cases of data, identify patterns. We're going to do some very quick exercises, put data together, put a data set together, identify noise and deal with missing data. Talk some more about data in general. And then we're going to build a linear regression model. Now, I'm trying to manage time. So as much as possible for the introduction, we'll spend 20 minutes. And for the data roles, this is just going to be all talk. And I know so many people have questions about how they can begin this data science journey, but then I'm going to talk about data roles in general. So it's not just going to be data science. We'll spend a lot of our time with linear regression, which is 60 minutes. For questions, that should be 25 minutes because I expect that you have a lot of questions. So let us begin. Next slide should be about me. I'm not going to say much. I'll only share my website. I'm a senior analytics associate at Syntelli Solutions. It's a data and analytics company, and we do a lot of things for social good in general. And if you want link up with me directly, you can check my website, read about how I started, and you can reach out to me directly from there. All right, so the next thing we'll watch a video, which I need to be sure you can hear the sound. So I'm going to check on some settings here and then play.
Then I just know you see my child, I bring it. Papa.
Awesome. All right, so. Right. So the reason why I decided to share that was, as you can see, for those of you that already know about data science, that's not data science per se, right? Precisely. It's just to tell you the power of data. And a very good way to look at that is we all live in a city, we all live in, in a common space, but then we do different things. But we see how we can make this common space better for everybody. And that's where the whole idea of smart city comes in. It shows you how data can be stored in different ways and how that same data can be used for different things. So let's look at data in general. Data is everywhere, right? It's everywhere. When you think about all of these examples given to you, we pay our bills, we go to the hospital, schools have school records, student records, the banks have your financial records. When you go to the store, whether you're buying online or in person, they have your records. They have records on what they sell. When you use your phone, there's also the contact details. It has records of your friends and families. When you look at sports, you see how analysis is done, what happened last year or 4 years ago, and how you talk about a particular player or a particular athlete. And then even with our video games, everything is all about data. So data is not something you want to start thinking, I have to be a data scientist to start working with data. You can be an accountant, you can be a lawyer, you can be a fashion designer, you can be a carpenter, you can be anything. And you're going to be dealing with data, all right? So this is an exercise that I have for you, and we're going to run through all of these very quickly because this is just the introduction. Now, when you have all of these, you want to group this into two groups. What's the pattern? The pattern here is you have some shapes with four sides. You have another set of shapes that is circular. So you have quadrilaterals, four-sided shapes, and circles, regardless of anything else that might be in there, the color, everything else, right? So this is how to group it. Another example I have, another exercise I have is with the numbers. Now, filling in those three blanks, what should come next? So that's a way to think about based on trends that have happened over time, what's likely to happen next. So when you look at the trend 20 to 22 it's increasing by 2, 24 to 25 is increasing by 1. So it increases by 2 times and then by 1 time. And so what you have next is this. So this is learning the pattern, right? I really want to emphasize this because this is really what machine learning is all about. You're learning the patterns within the data, but why it's a machine doing it is because you're dealing with a lot of data. That's not something as a person that you can do yourself. You're going to make a lot of mistakes. You're going to run out of time, out of memory, because you can't keep as much in your head as a computer can. And you just can't do some computations as quickly as a computer can do it. So that's why it's machine learning. And you do that by training the machine, right? You train, just like we've all trained. We all learned all these things over time from our parents, from our environment, from school, from things just happening, right? So this is the foundation of machine learning. We study the patterns to classify similar things together, or we get to know how much they change over time and when they change. So you know, at this time I'm going to add 2, and then at this time I'm going to add 2, and then another time I'm going to add 1, right? So you know a particular time a certain change has to occur. So for the sake of those that are not in computing or probably still in school, I still left this. And I'm giving an example of a teacher. I'm giving an example of a teacher. You have a picture or you have an object and you want to gather information about this. This is how you put your data together. So what kind of information do you want to find out about this teacher? You can have so many things. You want to ask about the age, you want to ask about the subjects she's teaching, you probably want to know how many kids she has to know if she can relate to kids well, if being nice is important to you. And by the way, this was put together by my son, so some kind of questions or kind of information there might not relate with you, but it's very simple and it's just something everybody wants to know. You want to know where she lives, or if she likes games. So all of these are things that the kind of information you want to gather about a teacher, for example. And this is how you put your data set together. Now, the reason why I'm teaching this is to help you see how you can put a data set together in a table. It may seem very simple to some people, so please pardon me when I'm making it very simple, all right? We'll get into the little complex section very soon. All right, so you put your data set together this way. What you have on top is typically known as the heading, and then you have your rows, which will then be your records. And in machine learning, this is how you explain those headings. You call those headings variables, right? And then you have some that are called independent variables, and you have a particular one, usually one. It could be two sometimes, but let's just keep it simple as one, as a dependent variable. Now, your independent variables they can also be called predictors. They are the variables or the columns that will tell you what you're looking for. So for example, let me give you some information. What we're going to work on today is we're going to predict sales, right? And so many things make up your sales, but we'll focus on advertisements only. When you talk about advertisements, you're talking about the ads you place on TV, on radio, newspaper, or any other channel that you have. So all those channels will be your predictors, right? Because those are the things that you're adjusting to get a goal. And your goal is your dependent variable, which is also called the target. So I have all of these records here, and this is your data set. Going forward, I'm going to start using these terms. So I will slow down a bit so you can get used to them. Remember, independent variable or predictors are your dependent variables or your target. Now, in real life, this is a very real thing. Sometimes we try to gather data, and as some of you may know already, sometimes data might not even be available, like the entire data is not there. And sometimes you have some data and you have some things missing. It could be missing maybe when you did your survey, maybe it was optional, or it probably wasn't even optional and someone did not answer that question. Or it could be the way it's stored. It's stored and maybe something went wrong, or it could be the way it was entered into the system. Someone didn't do the right thing. So these things happen. And in this case, where we're trying to predict who a good home tutor is going to be in a child's school, teacher rating is definitely very important. For you to teach a child, you need to have the skills to teach, right? You should be a good teacher. And that's what teacher rating is. Teacher rating, teacher ranking, all that same thing. Now, it's missing, and there are various ways to do that. The best way to fill in a missing data is to get the data. If you can call the person, you can ask the agency or the unit in charge, you find out where it is and fill it in. But it's not always possible. So what do we do? So other options are, you can use the mean or median. Most of the time, people use median often. So if we get the mean, we get that to be 8. If we use median, that's going to be a 7. So those values will change. And I intentionally changed it so you could see how filling in a missing data could have different values as well. So you can see just using these two methods, you're already getting 2 different values. Now, there are other methods that you can use. I'll talk about other methods and then we'll talk about what we have on top. So what other methods do we have? Recover the values, educated guessing, right? Educated guessing. And that's why when you're dealing with a data set, you don't deal with a data set without having some knowledge about that data. You don't just go in and start messing around with it. And we'll still talk about that, which is the role of a data scientist. And then the third one is imputation. Now, imputation can also be done in various ways. What we did there is actually imputation. It's one of the ways to impute data. There are other systemic ways where you use the entire data set and follow the pattern again to guess systematically that missing data. Now, it's not every missing data you need to fill in, right? There are certain things that you want to look at before you begin to address missing data. What's the percentage of what's missing? So I have an example here where I have 4 records, right? There are 4 teachers here, and I only have 1 missing. I mean, if 2 teachers have 7 and 1 has 9, it's a good way to guess. Like, okay, teachers tend to do well. We can assume that. But imagine I had just 1 record. Imagine I had just 1 record and I had a 7. How am I going to assess the remaining teachers? What's the best way? Do I want to guess they're all 7? Or do I just want to randomly put numbers there? Or do I want to look at other variables to assume, well, if this one has 3 kids, I'm sure she will have learned more lessons than these other ones. You can begin to look at those things, but then it could lead to something else, which is called bias. Bias being you're using your own judgment, right, to decide a goal, kind of, or maybe the way the data is positioned, it's positioned in a way that it's making you think in a certain way. You're not being objective about the way you're assessing that data set. So when you have a high percentage, very high, maybe like 80, 90% of the data is missing, you probably want to drop it. That's an option. And then you begin to decide on a threshold. Depending on the kind of data it is, let's say, for example, it's healthcare data, and it has to do with heart disease. We all know very well that heart disease and weight, they're kind of together. The bigger you are, the more likely you are to have a heart disease. And you want to predict if someone can have a heart disease, but you don't have the weight. And in the entire data set, 90% is missing weight information. What are you going to do? The best thing to do is really to drop it, because you cannot, based on 10%, use that for everybody else. All right. So what threshold am I going to work with to fill in what's missing? And like I said, depending on the kind of data it is, that's what will guide you. Now, what's the strategy for this missing data? Am I going to drop it, or do I need to go look for it, or do I need to look for a way to gather that, start another survey to gather that information? Those are the things to put into consideration. Now we're going to talk about noise. What is noise? Noise is meaningless data. It could be gibberish, like someone just typed in nonsense, or it's good data in terms of good information, but it doesn't add any value to what I'm working on. So when you look at this data set, for example, and remember what we said, teacher rating, right? And this teacher has favorite food. I'm not going to be serving my teacher food at home, for example, or regardless of what you like, it doesn't matter whether you'll be a good teacher or not. I would say favorite food is noise in this case, because it's not relevant. Now, address also, it doesn't matter what your house looks like. It could be small, it could be big, it's relevant. That's also noise. Age, well, as long as you're a teacher and you know what you're doing, you could be old, you could be young, that's noise in this case. Name is also noise, really, but the only reason why you probably want to leave that just it's just to identify your records. There should be a way to identify your records. But name is noise, because regardless of whether you're Tola, Bumi, or Moyo, it doesn't add any value to whether you'll be a good tutor or not. All right, so come on. So just a minute.
Hi, Moya, your mic is still on mute.
Can you hear me now? Can you hear me now?
Yes, please.
Okay. All right. So based on what I've said so far, we're going to very quickly, all right, because this understanding is very important for, it's going to set the foundation for our linear regression. So let's predict whether the same teacher, the same data set I've been talking about, will be an excellent home tutor. So now we're looking at patterns in the data set, right? So for this teacher, we already have our target. Remember I said I'll start using those names. So we have our dependent variable, which is our target, which is the last one there, good tutor. And we have all the other things. I've taken out the noise. I hope, yes, I have. And now, for every teacher that is considered a good tutor, what do you see that is common to them all? So let's look at all our yeses. So the teacher grades, they all have above 5, right? Or above 6. There's no 6, so yeah. And then all of them, are they all fun to be with? They are all fun to be with. Do they all like YouTube? No. So you see this Mr. C doesn't like YouTube, and he's still a good tutor. Are they all nice? Yes, they're all nice. Does it matter the number of kids they have? No, it doesn't matter, because Mr. C still has no kid, and he's still a good tutor. So that brings us to this equation that we have here, which is for you, the equation, and if you're not a math person, don't be discouraged, okay? So the equation here is determining a good tutor means you have to be nice, you have to be fun to be with, and you have to be a teacher with at least above 5 teacher grade, okay? Now, what you've learned so far, we've learned the fundamentals of machine learning. This is just to tell you that I'm wrapping up the introduction. Those are the patterns. We've been able to put together a data set, and that is highly useful when you need to collect data. Now you understand dependent and independent variables and how data is used in our everyday lives. All right. All right. So we're moving on to the next segment, which I will pause and do a lot of talking and answer some questions. But I really like this. And I'm putting this up because someone asked about law firm, how data science is used, how can it be used in law? So this, I got it from some law firm. I don't really know them. I just looked it up and I saw this quote on their website and I thought, this is perfect. So law firms without outcome data are like basketball teams that don't keep score. And I know you guys, a lot of you like sports. So imagine watching FIFA, or you're watching Arsenal and Manchester, and whoever scored last year or 2 years ago or 10 years ago, they didn't keep any score. What kind of analysis are we going to be talking about now? In fact, how would that help you in choosing the team you're going to support? So analysis is very important regardless of the field you're in, right? Data is important regardless of your field, regardless of your function, your job role. Okay, so now we're going to talk about a lot of data roles. And while I'm talking, I have the data set that we're going to use. Please go to that link, download it, and then I'll begin to talk about the various data roles that we have. Now, not everybody has to be a data scientist, but everybody has to understand data. Okay, that's the most important thing. And when I say everyone has to understand data, it's more about, because we all kind of have an idea what data is, but then we don't take care of it the way we should, and the way it's going to help us in our jobs or in our businesses. All right. So I'll begin with my far left, business analyst. Now, who is a business analyst? While I'm talking, please go ahead and download data, because we're going to start working on that right after the session. So a business analyst is someone is the intermediary between IT and business. They usually handle data models, they design the workflow, and they need to have business knowledge, right? I mean, they're in between. So they need to have both business knowledge and IT knowledge. And now the last box is the kind of skills they can do related to data specifically. They can write simple SQL queries. Not all of them, but they should be able to decipher by reading a SQL query that, okay, this is what you're trying to do. Now, for the next three, excuse me, please. For the next three, I have a DBA, data architect, and a data engineer. And I intentionally group them together, and I'll tell you why. But before I get there, I'll talk about a DBA. DBAs are still very relevant, because I hear everybody wants to be a data scientist and nobody is really looking into DBAs. Database, they ensure that database is available and high performing, and what they're focused on is online transactions. That's their number one job. So anything that is related to online transactions happening, storing those records, granting those requests, making sure it's secured, they're the king there. So they have advanced SQL knowledge. They need to have some networking skills. They need to have database design skills. Like anything you can think of about data, they have to be there. The only thing is, oftentimes their core focus is online transactions. Now, a data architect is like the name goes, architect, right? You're creating the blueprint for data management. And most people don't just become architects. They don't just go to school and become architect. And this is why, because as an architect, you're developing, you're coming from experience, right? You're usually coming from experience. You're telling people, the business, the company, that, oh, I think this is what is the best way to handle this situation. And you can only speak that way because you've tried out the tool, you've seen it work before, you've had some hands-on experience with it. So they also do data modeling. They drop the pipeline. This is what comes here, this is what comes next, this is how they integrate. And they usually, data engineers, the DE I have there is data engineer. They're usually data engineers, they come from that background with so much experience with tools. Now, a data engineer is very similar to a database administrator. Now, the difference is the way they handle analytical data, right? So they're dealing more with warehousing, the data lakes. That's not online facing. That's not what makes your ATM pay you money. So they can also drop a pipeline. Now, they're different from architects in the sense that oftentimes they have limited knowledge compared to architects. Not that they don't know anything, right? They have limited knowledge. They have an area of focus. They also handle data models, and then they do ETL. They're the ones ensuring the entire extraction from the DBA's space, and then the transformation for analysis the whole loading process and ensuring that in this analytical area, that data is available for everybody else afterwards, data scientists, BI developers, data analysts, and even business analysts, right? So they also do advanced SQL. Now, they are the ones that tend to learn more about the big data tools. That's the difference again between a data engineer and a DBA. A DBA usually does not really know much about relatively. Everything is relative, okay? So I won't say that again. Big data tools. Advanced SQL, Python, Spark, Hadoop, and IBM tools, and all these really plenty fancy tools out there, okay? Now, a data scientist is now then dependent on a data engineer who will then say, well, I need because a data scientist is working in the analytical space where you're now analyzing data, building machine learning models, and making the robots. So someone said, what's the difference between AI and machine learning? And that's basically AI is a broader picture under which machine learning comes under. So on that, for AI, you're talking about robotics and so many other things. Machine learning, you're talking about the machine learning, building the models for them. Now, a data scientist always requires business knowledge. That is so important. It's just as important as knowing how to write your codes. You should be able to understand why the business is going this way. And yeah, oftentimes you see data scientists that there's an imbalance, right? That's understandable as well. But that's why data scientists don't work alone. They always work with the business, because a data scientist will analyze the data, will see the trends, will be able to show the trends, but may not be able to interpret it. And so he goes to meet the business person and says, this is what I'm seeing. Why do you think this is so, right? Why do you think this is happening? Why do you think when oil price is down, this product is expensive? Or I just noticed that when this is down, this goes up, or when that's, something like that. And then they have those skill sets. They use R, they use Python, they use statistics. That's what stats means. Some of them can work in Hadoop, not a lot of them. Hadoop tend to be seen as a data engineering tool. A lot of them don't function as IT staff, right? You would think because they're writing codes, then they should be in IT. No, oftentimes they don't work with IT. Oftentimes data scientists are in business teams. Now, moving on to BI developer. So a BI developer BI means business intelligence. You're analyzing data for the business. You're developing interactive reports, dashboards, you're connecting to that analytical space also, as well, or probably to the DBA reporting databases, depending on how it's built in the organization. They can write simple SQL queries. They use tools like Power BI, Tableau, several of them, okay? And then a data analyst also who collects and analyzes data, and they code more than statisticians. They do some form of statistics because they're aggregating and they're summarizing the data for the business. Now, they tend to write more complex SQL queries than the BI developers. They can work in Hadoop, and they're just as good as the BI developer as well, okay? Now, these are just titles. You see in some organizations that one person is doing almost everything, seriously, even till today. And I'm just trying to tell you where you can fit in if you really think you have to fit in somewhere, where you can fit in with what you like, because not everybody can write codes, not everybody likes writing codes, it's not everybody that likes statistics. So there's still something you can do, all right? You don't necessarily have to be a data scientist. And if you want to be a data scientist, this is what you need to do. You need to know math, you need to know statistics, you need to be very comfortable with equations, algebra, statistics. You need to have some knowledge of the business. Now, you can call yourself a data scientist, or you could even be very specific and say, my domain, which is the business that I'm working in, is strictly health. you could be a lawyer and say, well, this is what I do, and so I can only function, so well in law. It doesn't mean you cannot apply that same skill set in retail. You can, but the way you're going to be able to interpret the business, it will be different. You probably will need some retail expert to help you there. And then you still need some level of software development. And that's I would say, as a data scientist, that's usually the challenge. Most data scientists are not software developers. They can write codes. That does not make them a software developer. They can write codes. They understand statistics. They understand the business. I mean, you can acquire that knowledge over time, right? But when it comes to integrating the application with existing applications, which is still a stage where we're yet to break through, it's always a problem, right? I have my Python code here, but then this code is Java. And so bringing Python and Java to function in the same space becomes a problem. So if you want to be a data scientist, this is what you need to be working towards. And you cannot work towards this by just going to school and studying computer science and saying you're done. No, study computer science or study whatever you're studying, but then acquire all these other skills outside of that, right? So it's challenging to start with, but then you can build on top of it as time goes on. So I will pause here. Did I stick to time? I'll pause here and entertain questions. Let me go to the chat.
Okay, everyone. So please feel free to drop questions in the chat section, both on Zoom and on YouTube Live, and then we'll take them one after the other. Questions, questions, questions. Okay, while we wait, can we take a couple of questions from those that sent in entries before that sent in questions during registration? So I'm taking a question from Adebesin Adedayoluwadamilola from Oyo in Nigeria. He says, thanks for the opportunity. Is a platform you can help with for learning apart from online? She's pursuing a career in data science and she feels it's overwhelming and tiring to do her learning alone. So are there platforms online that she or he can check out to continue our learning?
Yeah, so that's a very valid, I know that challenge, yeah. So there are free resources. If that doesn't work, I still have other opportunities outside of this. I'll suggest you contact me directly through my website. When we're sending out information about this session, we'll also send out applications or places where you can register and learn and learn free of charge. I'll send that, but I can say them now. You probably know them and you use them. edX, there's edX, there's Coursera. You can learn free. They're not going to give you any certificate. Now, if you need to get a certificate, that's when you have to pay a certain amount. I'm not sure how much it costs. The best way to learn, depending on who you are, you don't always have to go to school to learn and spend so much money. But if you really want to do that, that works. Some places would ask you for a degree. Some places are fine with you showing your GitHub account. Some places are fine with just showing what you can do. But the most important thing is being hands-on, and that's why we're doing this today.
Okay, awesome. Thank you. Decanti on YouTube asks, it says, as a designer, I want to learn how to deal with data to make better decisions. What do you advise I focus on in the early stages of my learning?
I'll say focus on image recognition, right? because in fashion, so I'll just say fashion in general, designer, or it's all about designs, right? It's the design that is appealing to people, and that's what they're buying, right? So you want to focus on image recognition. And there's some other things that, regardless of your area of specialization, you still have customers, right? You still have marketing. So all those things still have some form of science to it that you can learn.
Okay, awesome, thank you. Is machine learning, this is from Ulasika on Zoom, is machine learning and data analysis really helpful for a BVN startup? Moyo, I think your mic is on mute again. Can you hear me?
Yeah, I was asking you to unmute me. That was like,
oh, sorry about that.
No problem. Is machine learning helpful in, could you?
A BVN startup, that's the, the biometric verification system we have in Nigeria that banks use to verify users and all.
Okay, I'm thinking through the use case. Is machine learning helpful? Helpful in terms of like fraud detection, or helpful in terms of just...
Yes, likely to be fraud detection, recognizing patterns of financial transactions and all of those.
Okay, so machine learning is helpful. Yes, that's a very solid example. I'm just trying to answer the way the question was asked. It's very specific to BVN, right? So you say if this particular BVN ID tends to do 10,000 every day, every once in a while, and all of a sudden this BVN ID is doing 50,000 or something, that's very odd. Or you're doing a transaction from an unusual place, or two transactions are happening from almost two impossible places at the same time. Yeah, so yes, that's what machine learning does for you. Remember what I said, that machine learning, you're using the machine for the speed and the computation that's going to happen. As a human being, when you see those things, you can tell them this is awkward. But imagine 50,000 customers or 1 million customers doing that at the same time. That's what machine learning is for.
Okay, awesome, thank you. How is data and a data architect different from the data engineer? Their role seems to be closely related. This is from Ephraim Ebong on Zoom.
That's a good question. Now, a data architect, first of all, usually would have been a data engineer from the beginning, right? Because of they have some hands-on experience. They know what works best. They know that when you do it this way, it's going to take a longer time for it to run. Now, in terms of what they really do, an architect is just telling you how to build the pipeline. This is how to work. Now, when it builds a pipeline, it tells you move data this way. And when you move data this way, creates this account for security purpose, for audit purpose, and then even creates space for the data engineers to work, and another space for the scientists or all those other guys, BI developers and analysts, to function. Okay, so an architect does not get hands-on. An architect is not going to be writing the code. No, an architect is just going to draw a plan for you that will help everybody else function well. But then a data engineer is the guy that will go there and write the code and then join this table to that table to make it the way you want it for the data scientist and other analysts to function.
Awesome, thank you. One question, which of the data roles pays best? Talking about averagely now. This is from Abbas on Zoom.
That's a difficult question. I would say it's between the data engineer and data scientist.
Okay, awesome. Okay, there's a question from Jesse Amadose. Sorry if I didn't get the pronunciation right. Good day, Moyo. The construction industry is known to thrive on data. However, studies has also shown that it's among the sectors that lag behind in using data. What do you have to say to someone who wants to use data science in improving the construction industry?
Okay, so construction will be building roads, optimizing the infrastructure, or is it like that's how I understand construction to be? Construction will, I mean, data science or data in general will show you the plan. I'm thinking through that. So in terms of construction, you're looking at how best to allocate resources, right? When you have your data, you know that in this area, I have this amount of land, or this amount of people will be staying here. So I know how best to allocate my resources. If I'm going to have 3 people looking into that section, or I need to put some IoT stands in certain places, then based on the people that are there, I know how to build my capacity to cater for their needs. I don't know if that's the kind of construction you're talking about. So, but then if you're looking at things like building a house or building a bridge or building in general, then I'll look at things like the design and the errors, handling the errors, the faults, tolerance, and things like that. So having your data set and coming up with a plan is like, what's the optimal way to construct a building that will cater for this certain number of people? How many bricks or blocks, or those kind of things do you have to put into consideration? If you research linear programming, it's different from linear regression. If you research linear programming, it will give you an idea of ROI, returns, and optimization techniques. Yeah. Olumide.
Sorry, I was on mute also. Yeah, thanks, Moyo. Mofinifoluwa asks, what's the best pathway for a data scientist, for a data science or data engineering career with respect to software development?
So you need to learn about computers. Like, just have, well, it depends on where you're starting from. So let's say you don't have a clue, right? So you need to understand how computers work. Just have a basic understanding of internal workings of computers. Then SQL is always a good way to go. I am surprised SQL is still very relevant considering the way things are going. It seems like every tool that comes out there is tailored to, be useful for those that already know SQL. So knowing SQL, the basics of SQL is so important. Almost everybody here that I have on this screen should have some knowledge of SQL. Know SQL, and then begin to learn statistics. Right? That's if you want to be a data scientist, you have to know statistics. If you want to be a data engineer, then you really need to be very good at SQL. So SQL, statistics, depending on the path you want to follow, and then begin to climb the ladder, go and learn precisely what data engineers do or precisely what data scientists do. One last question, and then we'll move on.
Okay, one last question from YouTube. That's from Woke Wonder. What next after a PG data science and business analytics knowledge of R, SQL, and Python? What would you suggest?
What's PG?
So I think that's a postgraduate data science and business analytics knowledge. So either a master's degree, a PGD or something.
Okay. All right. So whenever you learn anything, right, you learn it for a reason. You don't just learn to know it. You've learned to apply it. So begin to apply it. Sit down and look for problems to fix. That's the best way to show people that you know this. That's the best way to make an impact. So it's good to have pay, right? I'm not saying don't go for the pay. Go for the pay, because when you go for the pay, then you're able to bless other people, I hope. So, but more importantly, you want to deploy that knowledge into real life solutions, right? So that should be your next step. Go to Kaggle or look around you. Look around you. It could be a school. Often go to a school and say, I can help you, put your data to use and make life a lot easier for all of you. It could be a federal government school nearby, but I know that would be a lot because that's federal government. But you know what I mean? Just make use of it. All right. So I'll move on from here, Olumide.
Yeah, thank you.
Thank you too. I hope we all have our data set. And so we'll talk about problem statements. Now, this is what we're going to work on today. You own a business and you really want to know how your advertisements are impacting your sales. You have a gut feeling, which almost every person that does something, you always have a gut feeling about what you're doing, but you can't really tell the primary factors driving your sales. So that's what we're going to do.
Moya, please, before you proceed, hello everyone. The link to the data set is in your chat boxes. So both on Zoom and on YouTube. So please download it so that you can follow along with the class. Thank you.
Thank you. So now we're talking machine learning, okay? And machine learning doesn't always have to be code. I intentionally made this codeless so that even if you're accountant, you can understand, because I think Excel is a good way to start. So I'm going to use Excel. All right, so machine learning methods. We have two methods: supervised learning and unsupervised learning. For supervised learning, this is where the target variable is known. You know what you're looking for, and you're looking for the relationship the independent variables have on that target. For unsupervised learning, there is no explicit definition of what the target is. You just have this mass. It's massive. Well, it doesn't have to be massive, but you have this data set. You don't have a clue what it is. But then you tell the machine to learn it. That's what it's meant for. And find the pattern and give you answers. So my question now is, this model that I said we're going to build, is it going to be a supervised or an unsupervised learning method? I'm looking at the chat now to see who's going to get that right. Let's make this interactive. Thank you, Abbas. So it's supervised. Thank you, everybody. So it's supervised, and now that I've learned something on Zoom, this is human learning now. And I hope you can all see what I'm drawing. So I have a question again. Do you think how do I close this? Do you think that a person selling something, whether he advertises or not, do you think he's going to make sales? Golaga, Jesse, yeah, so you're all right. He's going to make sales, okay? So I'm going to show you, and if you don't like graphs, don't worry, just follow along. I promise you it's going to be easy, okay? Now, because he's going to make sales, now this lines are drawn. I have my Y, which is my sales, okay? And I have my X, which is my advertisements. We call that ads. All right, and then this is 0. Now this point means no sale, no ads. Basically, that company doesn't exist, right? Where I have this point here, right? No sales, no ads. That means the company doesn't exist. But then because we said whether he makes an ad or not, he's going to make some sales. So that means, let's say he's selling $5, for example. Now the graph is going to look like this for linear regression, okay? I'll explain to you why it's this. And what this means is without an ad, he's selling 5, making 5 sales. Now, when you look at this point, right, we're looking at certain points. We'll look at certain points on this slide and we'll try to understand what they mean. So here, he has started making an ad, right? And let's say he spent $2, but then he's earning 7, or he's making sales of 7. And then the same thing here. Can anybody tell me what's happening here? All right, I'm going to the chat. More ads equals more sales. It's increasing. Sales are increasing with ads. Increasing. Awesome. So that's a linear regression. Okay. So sales are directly proportional to the ads. I like all of that. Thank you so much. So now you know what Y is. Y is your target. So that's another way. I know some people struggle with letters for numbers. So when you hear me say your Y, it's also your target. When you hear me say your X, those are your predictors. It could be many, it could be one. Okay. Now moving on to the next one. Okay, so I need to clear this. How do I clear by annotation? Eraser. Oh, there should be a button to just wipe it off. All right, sorry guys. I deal with data. Okay, so remember what we talked about the teacher, right? We said for you to be a good tutor, you have to be nice, fun to be with, and have a score above 5. And so the equation is same as y equals a plus bx. X here is nice, then another bx2, which is fun to be with, and then another bx3, which is good teacher score. All right, so look at y and your x again, the variables. We'll talk about b and a. You understand that over time, okay? But your b is the slope and your a is the intercept. Now I'll talk about intercept now. Intercept was at 5, which meant even though that guy did not sell anything, he was still making a sale of 5. So that 5 is what you call your intercept, okay? And I think I'll move on to Excel now. So let's get Excel ready. Oh, okay. So now we're talking about linear regression. What's linear? Sequential, moving along in nearly straight line. That was what we saw. And regression in statistics, it means a measure used to determine the relationship between variables. So we saw ads and we saw sale, and we saw how it was increasing with time. Okay, so the overall idea of linear regression is you're looking for variables that do the best job in predicting your target. That was the same thing we did earlier with the home tutor. How much change in that variable, in that independent variable, will drive a positive change in my target? Is it when I do 2 ads, do I get 3 sales, or do I get 1 sale, or do I get half sale? So that is the coefficient. I'm still going to talk about it. So I'm saying a lot of things, but don't worry. And you get some of these. I'll put them in the Excel so you can always access it. Now that change also, is it going to be positive or negative? Now, I know I didn't say much about that. Let me quickly draw something. Remember, this was what I did before, right? It can also be like this, right? So it's just the reverse, which means the more I spend on this, the less I make, right? So I'm making less. Every time I spend more money, I'm making less. So when you look at this point, and you look at this point, I came from 7 and I dropped to 5, as whatever this factor is increasing from 4 to 6. So the more of this I do, the less the money I'm making. What does that tell you? You do less. So make sure you're staying somewhere here, right? And that's something like cost, right? The more money I spend on this thing, the less my profit is. So maybe I need to look for a way to control my costs. All right. Clear all drawings. Yeah, awesome. Okay, so moving to Excel now. I'll stop sharing because I don't think I'm sharing my entire screen. Let me bring up Excel. All right, Olumide, if you can't see my screen, please talk. If you don't talk, I'll assume you can see it.
I can't say it.
All right, so this is what everybody has. I have slightly more, okay? Now, we have all of these and we've talked about this, so we're not going to say much. Now, for you to begin your analysis, click on data here at the top where you have your menu bar. Click on data. When you click on data, on the far right, you see data analysis or analyze towards the extreme right. There's data analysis and there's solver. So click on data analysis. When you click on it, a new window is going to pop up. On that list, look for regression. It's arranged alphabetically. So click on regression and click OK. I'll pause for 5 seconds.
I hope everyone is following along. If you have any issues, please raise them in the chat so that we can help resolve it immediately.
All right, so now remember our target is sales. We want to see how our ads are affecting our sales. So input Y range, that's the same thing as your target. What's my Y range? I'm going to select everything from D, the entire D column. I like to use only, so I think we have just 200 records. So from there, highlight everything there. A quick way is hold down your shift and down button. It highlights everything you need. And then input X. Now let's start with one of them only. Let's start with newspaper. Don't do everything, and I have a reason for showing you that. But please watch me because I'll have 2 different people volunteer to do radio and TV, okay? That will make it faster. Oops. So I need to do this again. In your input Y, and then input X range. Remember I said X range, we're only doing newspaper. So input together with the title, okay, it's very important, and I'll tell you why. Together with the title, so you have newspaper and you have that as well. Now, the check boxes under that, you have labels, confidence level, constant, check labels. If you don't check labels, it's going to treat that label, that heading that you've selected as, it's going to give you an error. Okay, now the label is important so that when you're interpreting your results, you know what you're interpreting. It's not just going to give you variable 1, variable 2, and then you're guessing which is variable 1 or 2. Output options, leave everything else as it is. Don't change anything, and then click OK. Let it be new work supply. That way it's not messing around with what you have already. You click OK, and you should have what I have now. Any questions so far?
Okay, so a couple of people are saying they don't have the data analysis tab under their data ribbon. Okay, please just follow along. I would try to see how our technical team can help resolve that. Just follow along with the class.
If you don't have data analysis tab, then you're probably using an older version of Excel. I tried to see if any of these cloud tools had it. None of them had it, except, of course, Microsoft. So if your data set isn't complete, then you probably have to download again, okay? Go back to download. I'll quickly run through for everybody, for anyone that is lost, Golaga, Ogenejiro, anyone that is lost, I'll do a run through now. So please pay attention, okay? Go to where you have your data set, which is advertising, and where you have file, home, inserts, the top, the headings, where you have the menu options, look for data, click on data. Okay, this is what you typically, this is what you typically will have, but come to data, all right? Come to data, follow my mouse. I'm circling it so you can find it quickly. And then on the far right, you have data analysis. Click on data analysis and select regression. It's arranged alphabetically, so that will help you find it on time. Regression, and then click OK. Now, when you click OK, in the first place where it says inputs, it says input Y range. Now, that Y range is the sales that we're trying to predict. Okay, so your D cell or D column will be from, place your mouse, sorry, I'm moving too fast. So put your mouse pointer in that box where it says input Y range. So this is what you're likely to have, right? Click in there because you want to input your Y range. And then come out, don't close it. Put your mouse on sales and drag it down. Only D, right? You might not drag it down to the end where you have the last value, 18.4. And that's it, stop there. Okay, now put your mouse in input X range text box and do the same for newspaper. All right, so drag from newspaper where you have newspaper written, drag from there and drag it down, okay, to where you have 8.7. Make sure you have labels checked. That way we'll always know what we're working with, what label we're interpreting. And make sure you have new worksheet ply also checked, the button pressed, and then say OK. When you say OK, it's going to open a new page, a new worksheet for you, looking like this. All right, so who will like to do, I need 2 different people to do, oh yeah, there's a way to enable it under options in the file area. I'm sorry. Franklin, thank you. So you can enable it, and mine came enabled.
Okay. So could you please go to your Excel window, then on the file menu, select the options tab, then on the pop-up that comes up, select add-ins, and then load the analysis tool pack add-in. So then you should have the feature enabled.
So click on add-ins, and then which one has the toolpack VPA or Power Pivot? Analysis toolpack.
Yes.
And click OK. You click OK, and you should be able to see it then. All right, so can I have 2, while we get that ready, can I have 2 volunteers to do the same for, with this, what we just did is newspaper. Can I have 2 people do the same for radio and TV while everybody else is trying to enable their add-ins? And you can raise your hand or you chat if you'd like to do it, or I'm going to assign.
If you like to volunteer, you can volunteer. Please raise your hand so we can note the volunteers who would like to present their own information.
Samuel, are you using Microsoft Excel or Google Sheets? So Microsoft Excel always has file. If it doesn't, then I'm not so sure, because usually that's how you save and do all those options. Yeah, 2017 should have it. I can access data analysis and data icons. All right, so.
Okay, should I run through the process of doing it one more time? Because I also just did it for myself and it works fine now.
Okay. Want to share your screen?
Okay, maybe I do that. Yes, so file.
Okay. Are you done?
Yes, I am.
Okay. Thank you. So can you please unshare? And Abdul Hamid, thank you for volunteering. Can you please share what you have? I'm going to take this out. So I'm not sure, it's sometimes, yes, it would be nice to have everybody follow along. This video will still be available so you can replay it and see how to run a regression model. But please pay attention to what's being done so you at least you understand it. That's the most important thing, okay? All right, so when you do radio, Abdulhamid, would you like to speak to make it fast? And bring this thing out. So I'm trying to get my charts to come up, but no problem. So when you do the same, when you repeat that same process for newspaper, radio, and TV, this is what they all look like. Now, what I want you to focus on is the summary output, okay? Because now I'm beginning to explain everything. Please don't get overwhelmed. You don't understand it yet, that's fine, but you will eventually. So just follow along, all right? Now, when you look at just the summary section of it, this is what they all have. So this is the first one we did. And so your values should be exactly like this, okay? Your values should look exactly like what I have here. And I'm gonna start explaining to you what these mean. Now, when you have multiple R, the value you have here, it tells you how this variable, how it correlates with the target. Now, correlation is what we did earlier when I said for every increase in ad, this other one is the sale is increasing. Okay, so that's some level of correlation, which means a change in this variable is affecting this by this certain amount. Okay, and so when you want to choose, and remember what we're going for is what is driving my sales. So what do you think you should be looking for? High correlation to some extent, right? Some level of high correlation, and that could be dangerous, but let's keep it simple. But whether for price is high or not, it doesn't affect your business, right? You're not going to really pay attention to that, right? Any change in, that's just an example, any change in a certain factor is not affecting your sales. That's not, as much as it's good to use it, that's not where your focus will be. So you can see newspaper is 0.15, right? Is 0.15, and that's just a fraction. When you put the percentage, that's about 15.8%. So this is the correlation from newspaper is 15.8. The correlation, the closer to 1 it is, right, the better it is. So you want something very high. So this is 0.15, this is 0.34, which is good, 34, and this is 90%. So which one would you think is the best? TV is definitely the best because it has the highest, right? Now, when you look at R squared, and I have everything here, so I'm going to give it to you. Okay, so you see why writing notes is very important. Now, multiple R is giving you an absolute effect. It doesn't tell you in what direction it's going, whether it's positive or whether it's negative, like I drew it earlier, right? It's just an absolute effect. And you need, as much as it is good, you need to know what the relationship is, because that will guide you in making your decisions, whether to increase this certain factor or whether to reduce it. Now, what R squared does is it tells you the percentage of change in that target in your sales, the percentage of change that is caused by tweaking your variables. So let me bring that here again. So when I tweak newspaper ads, when I tweak how much I'm spending there, the percentage of change I'm going to see there is about 2.5%. For radio, it's going to be about 12%. But for TV, it's going to be about 81%. That tells you that your TV ads are making a huge impact on your sales. Now, adjusted R squared is exactly the same thing as R. The difference is adjusted R squared is when you're dealing with multiple variables together, okay? But remember, when we did this, we chose each predictor variable one by one, and that's why you have 3 of them here. So, and you can still see the values are still very similar. This one is still 2.02. This is still about 12, and this is 81 still. Now, standard error. Standard error tells you it's a measure of how correct the model is. So you want it to be as low as possible. You're going to be considering predictors that give you the lowest error margin, right? Now, when you look at standard error across, which one is the lowest? TV. Which one is the highest? Newspaper. That means there's something with newspaper that I don't quite get. I don't think I want to spend so much on my newspaper ads, okay? Now, observation is the number of records you have. Sample size, it's also called sample size. All right, so now we've talked about that top layer. Now let's talk about this, which is what comes next, okay? And still coming back here, the significance F in your results. I'll look at F, okay, well, I'll look at all of them. The significant F, which is this, this, and this. So everything I have highlighted is what you're looking at. All right, so I've placed them side by side so it's easier for us to compare. And now the numbers are not looking friendly anymore. I get that, but I'll help you. So the first one is newspaper. Newspaper is 0.025. That's a very small number. But remember, now we're talking statistics. Statistics is now very detailed. You know, you're not talking about multiple decimal places, okay? But you see, this is an exponential number. And what this really means is 0.12345638882. Right? Oh, so you can see it's back again. But this is really what it means if you look at how it's represented here. So when you compare this, look at the number of zeros you have there, and look at what you have for newspaper, which is 0.02. You can see this is very small. And this is just an exponent of 7. Imagine the one that has an exponent of 74. That tells you it's really, really low. And remember your significance F, you want it to be as low as possible. It's the likelihood that the regression is wrong. Okay, so you're looking, is my regression wrong or right? And the smaller the value, the better. So you see, it's still TV. Now your p-value, it indicates how likely the estimated coefficient, and I said we're going to talk about coefficient, okay? Now, these are coefficients. How likely is this coefficient wrong or right? These are coefficients, and I'll tell you how to interpret it, okay? How likely is it wrong or right? Now, the lower that value, the better. And there's usually a threshold. Most of the time in the industry, you say 0.05. It shouldn't be more than 0.05. That's, academically, that's what's used. So when you look at TV has TV has less than 0.05. You see it's -74, exponential -74. This is also less than 0.05, but this is also less than 0.05 p-value for newspaper. But then everything else has been not so good. Then lastly, we have the 95% confidence interval. Now, what this means is that this coefficient that you have, and what that coefficient means is for every radio spend, or for every TV spend, or for every spend, my sales will increase by my coefficient. So this is radio as an example, right? For every radio spend, my sales will increase by 0.12. Okay? For every radio spend, my sales will increase by 0.12. Now, what this means, it's repeated. What this means is I am 95% confident that it can be that my sale increase can be as low as 0.07 or 0.08, or it can be as high as 0.17. That's this value. And so even though my coefficient is 0.12, you can see it's in between, but it's giving you an interval, a range that the lowest it should be is this, and the highest it should be is this. All right. So now that we have that, what exactly is our equation, right? From what we've seen, which of these ads would you consider as your important variable? That's my question. And then we'll begin to talk about the equation. Which of those variables would you consider as an important variable? I don't know why my chat is not coming up. Can you help me, please? My chat is not coming up. I don't know where it is.
Okay. There's a chat icon at the lower part of your screen.
Lower part of the screen.
Yeah. Beside the participants.
Okay. I have it. TV. Okay, I see that answer. Thank you so much. All right. It's been very quiet. So, all right. So definitely it's TV. TV is a good one. But can anybody tell me why you wouldn't do radio? Is there any reason why you don't want to do radio? This is radio. I have radio here. The standard error is high. I like that. Yeah, so this video will be available on YouTube. Okay, so you can always watch it. So the standard error is high. That's a nice value, nice input. Now the p-value is still less than 0.05, right? It's still less than 0.05. So we can still consider it. Usually it's when you're looking at the p-value is what determines what goes in or stays out. Okay. Now we're going to do one last thing and then we'll wrap this up. When you put all the variables together, just like we did for each one, this is what you get. Okay, this is what you get. And this tells you your model is still very good. Why? Because when you look at the adjusted R square, remember now that we're dealing with multiple variables, this is what we're going to work with. The standard error is still okay, relatively 1.66. When you look at TV alone, it's 2.29, right? So when you combine all of them together, it's still doing very well. So let's leave everything. And when you look at the significance F, it's still very low, right? But when you look at these values, the P values, you see that newspaper is higher than 0.05, right? So now when we make it multi-variable regression, it's no longer simple. Simple is when you do one variable alone. Now, when you make it a multi-variable regression, what variables are you going to use? Answers on chat, please. When you look at all the variables based on this result I'm showing you on my screen right now, what variables are you going to use? TV and radio. Thank you, Jaffe. Yeah, thank you. So you're going to use TV and radio because they're the ones with p-values that are less than 0.05. So you take away radio. And now what that equation is going to look like. Remember what I said about intercepts? So now we're going to focus on coefficients. Remember what I said about intercepts? Your intercept is whatever what you're still going to have, whether you do your ads or not. And so your equation is going to be, remember what we talked about equations? Yeah. So your equation is going to be your y plus your a, which is your intercept. And so you say sales should be equal to, I think I can type this faster. What's the intercept now for that multiple variable? It's 4.63. Let's keep it simple. 4.63 plus, now remember we said bx, and your b is what? The slope of the line. That's the coefficient, right? That's the same as the coefficient. Your b is the slope of the line, and your b for the two variables that you're talking about, let's pick TV first. Yeah, I'm sorry, sir, Emmy. Do you have a question? Well, okay, so I can take questions from YouTube, from everywhere when we're done, and I'm almost done here, okay? So TV is 0.05. So it says 0.05 TV. All right, so we say sales is equal to our intercept 4.6 plus our slope for TV, the coefficient 0.05, 0.05 TV, whatever you're spending on TV, plus the radio 0.107, 0.107 times radio, okay? And then we're going to apply this same equation. We'll apply it here. So when you look at our test, we're going to test this. What this means is I'm going to spend this much on TV, I'm spending that much on radio, and spend this much on newspaper. When I spend all of these, I make this number of sales. Now, I'm not sure if this is sales in units or sales in money, monetary value. The data sets that I used did not explain it, so let's assume it's units, okay? Even though they have 17.5 units. All right, so if you apply that method or that equation here, using Excel, it's going to be 4.6 plus, and then, basic math, 0.05 times what you have in TV times this, okay? Trying to enlarge my screen. 4.6 plus 0.05 times what you have for TV, and then plus 0.107 times what you have for radio, right? And it's a formula, so you can copy, you can just make it simple, copy and paste it. All right, so this is what you predicted. Now, your ability to predict, is it the same? No, right? Right? It's not the same, but is it better than not having it at all? It is better than not having it at all, because you're able to prepare better and you're able to plan ahead, right? Now, what you call your residuals, which is what you see here, I have it here, right? For every prediction based on the analysis you've done, for each one, you have your residuals. Your residual is your residual is simply the difference between what you predicted and what actually happened. Okay, so when you do your machine learning, then you have to train. Training is identifying the patterns and coming up with your linear regression equation or coming up with the model, right? Now, when you've trained, which is seeing the data from historical events, then you apply what you've learned. You apply it on something new. Okay, that something new could still be part of the data you had before, which is what I did, exactly what I did here. I had this data before, but I want to see how well my model is working. So this is my prediction. This is my actual. This is correct, right? That's my prediction. That's my actual. My residual is then going to be what I predicted and what my actual, and how different it is. What's the gap? A lot of times I'm still getting zeros, right? Very low differences. And so that's the whole essence of having a model, something that you can use to predict the future. All right. So all right, so we have our equation. We've just done a linear regression equation, and we've done the simple one. The simple one will then be, if we're to do TV alone, our TV alone equation would be y. It will be sales is equals to the intercept 6.97 plus 0.05 or 0.06 with approximation TV. That's if we had done a simple linear regression, but we did a multiple variable, right? It's called multivariate or multiple variable regression. And so we have our equation. And so to wrap up what we've done, to summarize what we've done so far. Now we know the difference between a simple linear regression and a multivariate regression. We understand how to interpret the results of linear regression. I'm going to make those notes available in that same document that I shared, so you can take a look afterwards. You understand the different machine learning methods, that's the supervised and the unsupervised. And then we know how to derive the equation for making forecasts, and we're able to apply it. So, when you learn it, you're not just learning, but then you want to be able to apply. All right. Congratulations. We're done with that. The assignments that will come after will be sent as an email. And now we can ask more questions. Thank you. Any question?
Thank you so much, Moyosore. Yes, please. If you would like to ask questions, please either drop them in the chat box or you raise your hand, and then we'll give you access to ask your questions. For those on YouTube, the team will be keeping an eye on the live chat box. So please drop all your questions so that we can attend to them as soon as we get them. Thank you.
Thank you.
Okay. While we wait, we could probably take a few questions that were sent in during the registration. So just give me a moment. Okay, while we wait for questions, I think we can talk about the 3 months coaching and mentorship, so that people know how to qualify for it, the entries, and what you'll be looking out for. And then as soon as the questions come in, we can also take them.
Okay, so we're going to send out, that's TechQuest to send out the assignment, and anybody is welcome to do it. But preferably, if to qualify, I would appreciate students or unemployed people to benefit from the scholarship. And it's also going to be highly dependent on how well you apply what has been taught and how resourceful you are, wanting to solve a problem. That's really what I'm looking out for. It doesn't matter whether you're using Excel. In fact, I might prefer using Excel, so it's a level ground for everybody. So it's not about you being able to write codes. And if you think you want to do some research and show some skills, that's fine. But for the sake of those that have no prior experience, which this is, the main reason why we're doing this, I'm going to be limited just to what we've talked about now and how you've applied it. All right, so Olumide, do you still have one? Yeah, I'm reading through, and I understand everyone is asking for the slides. We have the video. We're going to have the video. I'll check with TechQuest if they want to share the slides. I'm going to make it available for them. What else again? I didn't show how I got the multiple regression models, Abbas. I did, but you can take a look at the video again. So there's a question from Akini. Does it help your model if it has had some data to work with beforehand, like having a model that has had some data to work with rather than one that is just working on a new data? So the process of developing your model is to study the data, not necessarily feeding from another model. You study the data and you come up with your own patterns that you've identified, and that's what forms your model. So that's essentially what machine learning is, just following the name, machine learning. You learn from the data, you come up with a model, and that's what you're deploying to new data. So it's always good to work with historical data because you're learning from the past. I mean, everybody does it, when we want to make decisions, right? They say, remember what happened that day? Don't go to that party. I'm sorry to ask. Okay.
Okay, thanks, Moyo. Bukola asks, so my question is basically, Bukola gave me on Zoom on data gathering. So say I want to create a ML model for identifying unclean water for drinking. How do I go about it?
Okay. All right, so that kind of, what constitutes unclean water, right? So that's an area I'm not an expert on in terms of the science behind it. Also, but let's look at it this way. When you're gathering your data, you say the source, let's say it's from the well, the components in it, all those chemicals, have everything in your database somewhere. And then maybe color, the taste, the smell, give it some score. If there's a way you can measure it, put the measures there, and then come up with your own final position. Is it clean or not clean, right? Based on all those measures, right? Now, have all of that data together, clean, unclean, clean, unclean. So the machine, just like we did for Good Tutor, the machine will learn and observe that water that is clean tends to come from this source, tends to smell like this, and tends to taste like this, and tends to look like this, or whatever qualities you've put together, right? And so whenever you pass the data about any other kind of, let's go, you go to a new village and then you take a sample and you want to test whether that water is clean or not, right? So you still need to put all that information that you used initially, the smell, the taste, the look, the source, and everything else, put it in the database, run it through that model just like we did, right? Run it through that model, and then it tells you clean, not clean, right? Now, there's a lot of engineering that has to go if you want to automate that process. There's some tools that will help you do all of that, that will help you, through the entire pipeline. And that's why the architect is necessary. That will draw the pipeline for you and tell you how to pass the water and how to gather the information and all of that. But I hope my answer has helped you understand how data science can be used for those kind of very social, economic kind of problems that you're likely to have.
Okay, awesome, thank you. David asks on Zoom, what of other unforeseen factors, how would they be incorporated into the predicted values?
When I say unforeseen factors, okay, well, when you run your model, remember you should always start your model with every possible data you have. If you remember what we did for the Good Tutor, right? We had everything. We came up with everything that we could think of. I just streamed it down to those few variables. But then think of anything you can gather all the data you need, or all the data you have. Let me say have all the data you can get. And then there are ways to identify important variables, or there are ways to knock off the noise, right? And one of them was what we looked at when we were looking at the linear regression, where we took each variable and we saw the multiple R, the correlation, and we're like, well, this is not relevant and that is not relevant. Based on what we've seen, the standard error and the multiple R, these variables are not relevant. Then begin to drop them off, take them out. And then with what you have, you then identify, even though this is relevant, maybe not so much, right? And that's how you begin to build your model. Now, when you build your model, remember, you don't stop there. You don't just say, oh, I have a model, fantastic, that's good. But then you have to improve that model. And the reason why you need to improve is because people change, especially when you're dealing with, the issue of water, for example. People change. There could be a new virus, or there could be a new situation somewhere, and your model is not aware. Your model is like a kid that you always have to train. You have to teach it. It's the only good thing, the only advantage your model has over you is just the ability to handle massive data at once. But you're still smarter in terms of you're logically thinking, I think I need to add this new data or this new event happening now. Let me consider what's happening. So improve your data. That's how you handle unforeseen factors.
Awesome. Thank you. Dikamsi from Lagos asks, I'm just getting started in artificial neural network in a university course I'm taking. I would love to know how the two are interrelated with each other. That's artificial neural network and machine learning.
So artificial neural network is a kind of deep learning, right? It's deep learning in sense that what we've just done right now is elementary, is very simple. Deep learning is when you have many networks doing different things, and at different stages they're coming together to aggregate results. But you see the word deep, it means it's pretty big. And so and they're machine learning models also. This kind of models will require a lot of, it's usually because they have a lot of data they're working with, and data in terms of variables. You can have some data set that can have like 500 variables or 1,000 variables. How are you going to deal with 500 variables or 200 variables, right? So those kind of networks will need you to pass them through a kind of a deep learning model where it does the computation on this, and then another is doing another, and they're aggregating results at different times, and then it eventually comes out with a result. So it's still a machine learning model, and it's just one of those different approaches. I won't necessarily call it an algorithm. It's a deep learning model.
Okay. Awesome, thank you. Festus asks on YouTube, good evening. How can we use the skill of data science and machine learning tools to predict the interest of customers in order to know the nature of products to develop that will match their desires?
So there's a feature in machine learning that is very important, and I probably should have touched on that. When you're building your model, you're looking at, apart from data extraction and all of that, you're looking at feature engineering. Feature engineering is you develop features yourself. Now, features are the same thing as variables that we've talked about. So, for example, let's say I'm looking at food now. What Nigerian foods are common? So someone likes fried plantain, and there's also fried yam, right? They're both fried, and even though they taste differently, but somehow most people that would like one are likely to like the other. So you can come up with a concept of fried yam because they like fried plantain. Now, this is not a recommendation. This is different from a recommender system. It's just you're coming up with new products based on someone's taste, right? You've identified the features that constitute that taste, which is frying. So maybe let's try fried yam. Let's see if they're gonna like fried yam, and then introduce them to fried yam gradually. Now, those kind of things, and that's why they tell you data science is more of an art than a science, because a lot of things you're supposed to innovate them, right? You're supposed to innovate them. But what machine learning is going to help you do is the important factors still, because I like fried plantain because it's fried. So that means if you bring something else that is fried, it's possible that I'm going to like it. So that's how you're going to design a new product, because you've identified the feature that made me like another product.
Awesome. Thank you. Thank you so much. I think those are the questions in whole. If there are still other questions you would like to ask, please feel free to drop them in either of the chat boxes from whichever platforms you're streaming the class on, right? And we'll provide answers to those as much as we can. I'm also aware that a couple of people in this webinar just joined, logged on directly from either the YouTube link directly from our YouTube channels, or you got the Zoom link from a friend or a close one. So for you to get our subsequent communications, could you please go to our Eventbrite pages and register, right? So that you can be part of the people who will be sending subsequent communications to, right? The slides of today's event, links to the videos, links to the resources, details on how the assignments are going to be judged, the criteria, and all those things, right? So please proceed to, at the end of the webinar, proceed to Eventbrite and kindly register for which of the webinars you participated in, either the earlier one, that's Introduction to Data Science, or this current one, okay? Yes, I think we are gradually coming to the end of this webinar. Can we please, I'm unmuting everyone now. Can you register for which of the
Answer Abbas's question.
It was very nice.
Moyo. Could you please mute the mic?
Hello.
Please. Yeah.
Yeah, Moyo.
Okay, thank you. All right, so I saw Abbas's question, and that's gonna be my last answer. So he said that to determine the best variable, the most important statistics values we would look at are multiple R value and the P value. I'd say yes. Look at those two, but just to reconfirm, because whenever you're building a model, don't forget maybe because can you please mute everybody?
Okay. I'm trying to trace the sound, and I still. Can everyone please look through their mics and mute yourself?
All right, so yeah, those two variables are very important, and but don't stop there. Whenever you develop a model, you want to be sure that you're sure. Okay, so check all those boxes. That will give you the confidence that you're on the right path. And then when something unusual happens, which could happen, what we did is very simple, but then anything could go wrong. When you expect something to be low and it's suddenly high, then you begin to question, is it bad data? Is there something in my calculation somewhere, maybe the engineering process that is wrong. So don't just say, well, I've checked A and B and I'm good and I'm done. Okay. Check everything to be very sure. That's for Abbas. That's all. We can wrap up so we don't keep everybody. Thank you so much, everybody. I really appreciate your time. And I hope this is a way to start thinking about data differently. Please don't limit it to just sales and what you do, but extend it to how you can help the community as well. All right. Thank you so much.
Yes, thank you so much, Moyosore, for that enlightening session. On behalf of everyone, I must say thank you, thank you, thank you. On behalf of all attendees and the TechQuest team, thank you so much for the time and the commitment and the willingness to share your domain expertise with us. We hope we put this to effect and will make to use and will make you proud in the next couple of days or weeks. Thank you, thank you, thank you so, so much. And I think this is where we say bye, everyone. Have a lovely rest of your evening. Thank you so much for joining in. This is a TQ webinar series. We are still going to be bringing other domain experts in the coming weeks. So please look out for the communications on our platforms, on our social media platforms, on our websites. And then you could also subscribe to our newsletters, so you get all these kinds of information to you, sent to your email box. So thank you so much, everyone. Thanks for a wonderful session. Have a lovely rest of your evening or morning or afternoon, wherever you are. All right, bye, everyone. Bye.
Bye.
Yeah, thank you.